Hi, good day to you. In this video, we will be covering separation and purification. So why we need to separate things so we can study them on its own. We can purify certain items because we can use them. It doesn't harm the end user, for example, medicine. So a pure substance usually is characterized by a consistent melting or boiling point or a single spot on a chromatogram, which we will cover later. So simple, separating solid from liquid, for example sand and water, where one item is solid and does not dissolve in water, we can use filtration, filter funnel, filter paper, fold it up, and this is how you do it. The sand is the residue, the water will be the filtrate. Okay, next will be evaporation to dryness, usually for items that are heat stable. And the easiest example over here will be salt, table salt, sodium chloride, NaCl. So usually to harness the salt from the sea, it is evaporated through dryness because NaCl is heat stable. You can just put it in this setup and boil off the water. Crystallization is pretty similar, but you cannot boil off all the water because the substance is heat unstable. A very common example will be sugar and water. If you melt sugar, it starts to decompose and becomes a caramel-like substance. So you need to use the similar setup, boil off most of the water and just let it cool. The crystals will form. The particles will bring together some water molecules and form crystals along with it. Leave it to cool and crystallize. Filter the crystals, wash with a little bit of cold distilled water and pat dry between sheets of filter paper. That's where you collect your crystals. Okay, separating two solids. In physics, usually if there's such thing as a magnetic material, you can use a magnet to pull out all the magnetic materials away from the non-magnetic ones. However, here in chemistry, we maybe talk about things like solubility, soluble substances against insoluble substances like salt and sand. So you dissolve it in water, filter to get the sand, and evaporate to dryness to get the salt. So let's say if we want to get the liquid from the solution, for example a salt solution, we can do a distillation. A distillation maneuver. This is the setup. You have to boil it. The thermometer has to be at the mouth of the tube to make sure that the temperature that is of the steam that escaped is at the right temperature. The boiling chips here helps to ensure a smooth heating, as the chips usually made from ceramic or glass beads, that something inert to boil and move the liquid around. The condenser has to be set up in this arrangement. The water has to come in from the bottom so that the whole condenser is filled with cold water. So liquid boils and it comes over here, it condenses, and the distillate will fall into the container. However, if two liquids are miscible, they can mix with each other like alcohol and water. We have to use a fractional distillation. So this is the fractionating column. The boiling point of ethanol is 78. It's lower than that of water, 100. Ethanol will boil first. So of course some water molecule will escape as well. But however, it will get trapped in the fractionating column and condense and fall back down into the flask. So we can check at the top thermometer what is the temperature at the current point. If it's 78, we know that the distillate is ethanol. So when you start to see that the temperature is rising, you can start to switch the collection vessel to start to anticipate for water at 100 degrees Celsius. And of course, you can say that, oh, some of the liquid that comes out is going to be wasted. We will not know for sure because the temperature is not at the fixed point. And we must accept the fact that in separation techniques, we must anticipate that there will be certain levels of wastage. We can talk about this further in the metals chapter as well. Okay, so for fractional distillation, the boiling curve will look like that. This is where ethanol distills. This is where water distills. So when the temperature is rising, there may be some kind of wastage where some fumes, some liquid may escape. So fractional distillation are used for these purposes that we will explore in future chapters. Okay, next is chromatography. So for paper chromatography, the objective is not really to collect the separation for use, is more for a study of its components. So this is a setup. The thing you need to note is to use a pencil line because pencil lead, the graphite, does not dissolve and move along together with the water. The solvent has to be below the start line. So you can try this simple experiment at home where you draw a very dark spot using your pen and see what kind of colors make up the color of your pen. So this is for one sample. What if you have a large amount of samples? You use a larger piece of paper, you twirl them around and take them. Most importantly, the solvent has to be below the start line. If not, the samples will just dissolve downwards, not upwards, into the solvent. So how do you read the result of the chromatography? So of course the length or the distance traveled by the solvent will be called the solvent front, and certain colored spots will show that indicate the component of the particular sample. So if it has only one spot, it shows that the substance is pure because there's only one component inside this sample. So we can use chromatograms to compare and analyze what substances are within the unknown. Okay, and lastly, a method that is seldom talked about will be the separating funnel. Separating funnel is used to separate liquids that do not mix. Common example will be oil and water. So you put it in the separating funnel and you turn on the tap. Once you kind of reach the boundary, you turn it off and switch the containers up, and usually you will have to waste a little bit, especially when it comes to the boundary, because you want your collected samples to be pure. Remember that we need to anticipate some little form of wastage when we do separation purification techniques. And once you are sure that you can collect the next sample on its own, you can release it into another container. Okay, so as mentioned earlier, pure substances have one spot on chromatograms and fixed melting points and boiling points. And that is all for today. Hope you enjoyed this video. Give it a like and subscribe. Share it with somebody that needs to see this. And I will see you in the next video. Bye.